Dear students, Assalamu alaikum. Today our topic is sulfuric acid. The manufacture of the sulfuric acid by the contact process. Now, first I will introduce the sulfuric acid. It is an important oxo acid of sulfur. Oxo acid of sulfur. Its formula is H2SO4. It is also called oil of vitriol. Because in the earlier days it was obtained from ferrous sulfate, crystals, which is called green vitriol. It has oily like appearance, and because of its application in the industry, it is called the king of chemicals. It is called the king of chemicals. Because it has tremendous application in the industry. Now, we will take the contact process for the manufacture of this sulfuric acid. The process involves the following steps. Number first is production of sulfur dioxide. So, for the manufacture of this sulfuric acid by the contact process, first of all we need sulfur dioxide. So, how this sulfur dioxide is obtained? It is produced by burning sulfur or by roasting iron pyrite. So we will take the reaction S8 plus O2. This is how sulfur gets burned. It reacts with the oxygen, it forms SO2 8 times, and we have 8 times. Now again, by the roasting of the iron pyrite, FeS2 plus O2 forms Fe2O3 plus SO2. We will take 2 times, we will take here 4 times. Now we have sulfur, 4 2s are 8, here we will multiply it by 8 times. Now the oxygen is 2 3s are 6 and 8 2s are 16, 22 times. Here we will multiply oxygen by 11 so that we will get 22 times oxygen. Now the first step that we have done is the production of sulfur dioxide. Now next is oxidation of or catalytic oxidation of sulfur dioxide. The oxidation of the sulfur dioxide in the air is done in air in presence of the catalyst. So SO2 reacts with the oxygen, it forms SO3 twice. Del H is equal to minus 196.6 kilojoules per mole. This is a very important step in the production of the sulfuric acid. Now, if you will see that sulfur dioxide upon oxidation forms sulfur trioxide, it is a reversible reaction, and The forward reaction is exothermic and heat is evolved, that is 96.6 kilojoules per mole. In accordance with Literal's principle, the favorable conditions for this reaction are, number first, low temperature. As the forward reaction is exothermic, so low temperature favors the forward reaction. But the rate of reaction is low at lower temperature, so an optimum temperature of the reaction is carried at an optimum temperature of 720 Kelvin. So this reaction, that is the oxidation of the sulfur dioxide, which is reversible reaction, is carried out at an optimum temperature of 720 Kelvin. Number second is high pressure. As the forward reaction, you will see the number of moles is 2 and 1. 1 times O2 is 3, and here the forward reaction is, we have in the product only 2 molecules. So as the forward reaction proceeds with decrease in number of moles, so increase in the pressure. So we have to increase the pressure so that which will favor the reaction in the forward reaction. क्योंकि नंबर ऑफ मोल्स जो हैं, जब ये रिवर्सिबल रिएक्शन जो फॉरवर्ड रिवर्सिबल रिएक्शन है तो उसमें नंबर ऑफ मोल्स डिक्रीज होते हैं, इसलिए वी हैव टू अप्लाई द हाई प्रेशर विच विल फेवर द रिएक्शन इन द फॉरवर्ड डायरेक्शन, and pressure, optimum pressure of the 2 atmosphere or 2 bar is required for maintained for this reaction. Number third is catalyst, and we have number third catalyst. क्योंकि हम टेम्परेचर जो है वी आर कीपिंग द टेम्परेचर लो, द रिएक्शन फॉरवर्ड रिएक्शन is carried out at low temperature. In order to increase the rate of reaction at this lower temperature, we have to use the catalyst, which increases the rate of reaction, and generally the catalyst used are platinum or vanadium divanadium pentoxide. But as the platinum is costly, number one. Number second, it gets poisoned by the impurities present in the sulfur dioxide. So generally we use the catalyst, that is vanadium pentoxide V2O5, which is number one, it is cheap. Number second, it does not get poisoned by the impurities present in the sulfur dioxide like arsenic oxide. This is why we use the catalyst, and the next we need is purity of the gas. As to prevent the poisoning of the catalyst, the gas is freed from the impurities like arsenic oxide, dust particles, and moisture. And because with the purity, the gas is purified from this impurity so that the catalyst does not get poisoned. Next, the condition that is because of the Lecher's principle or that favors the reaction in the forward direction is excess of oxygen. In order to oxidize the sulfur dioxide into sulfur trioxide, we must have maximum yield of, in order to get the maximum yield of the sulfur trioxide, we must have excess of oxygen so that sulfur dioxide gets oxidized and forms sulfur trioxide. These were the conditions for this important reaction for the conversion of sulfur dioxide into sulfur trioxide, which is very important in the manufacture and is the prime step in the manufacture of the sulfuric acid. Now, the next is that conversion of sulfur trioxide into sulfuric acid. Conversion of SO3 into H2SO4. Now, sulfur trioxide is absorbed by the concentrated sulfuric acid so as to form the oleum. So, H2SO4 concentrated plus SO3 forms H2S2O7. H2S2O7, this is oleum. Now this oleum is diluted with the water in order to get the desired quantity, to get the, it is diluted with a H2S2O7 is diluted with a calculated quantity of water so that we get sulfuric acid of desired concentration. H2SO4, H2SO4, we have 8 times. Now this oleum, to the oleum we add water so that we get sulfuric acid. This point must be bear in mind that we don't add sulfur trioxide water directly to sulfur trioxide because we have a fog of sulfuric acid is formed which does not get precipitated easily. So first the sulfur trioxide, concentrated sulfuric acid is added so that to form the oleum, then this oleum is diluted with the desired, with a calculated quantity of the water so that we get sulfuric acid of the desired concentration. Now the plant used for this contact process is like that. Now this is the plant used for this contact process for the manufacture of the sulfuric acid. This is the plant, and now we will show the working of the plant. It first contains, number first is sulfur burner. This is the sulfur burner. In this sulfur burner, we take sulfur and this sulfur is burnt, or we take iron pyrite and iron pyrite is roasted in this to get the sulfur dioxide. Now, in the sulfur burner, sulfur is burnt and form the sulfur dioxide, and now the next is purification unit. It contains the following parts. Number one is dust remover or precipitator. number B is, after we have this dust remover, we have scrubber or washer. Next we have dryer, number D. In the after the dryer we have arsenic purifier, and preheater. Then we have number third is catalytic converter, and last one is that we have absorption tower. In order to explain this plant, this is the plant. In the plant, first we have sulfur burner, which is connected to the dust purifier or dust precipitator. Then it is connected to the column where the water is sprayed from the top, that is washing and cooling tower. Next, it is connected from that, it is connecting drying tower, and this drying tower is then connected to arsenic purifier, which then is connected to the preheater, and after preheater we have catalytic converter. This is catalytic converter, and then we have absorption tower. Now I will explain the function of these parts one by one. The first is sulfur burner. In the sulfur burner, sulfur or is burnt or iron pyrite is roasted so that we get sulfur dioxide. This sulfur dioxide contains various impurities of the gases and the impurities of arsenic oxide. First, it is taken in the scrubber or the washer. It is taken in the dust remover or precipitator, where we have the steam is taken and this dust is removed, or we have electrical precipitator due to which the dust is removed. Then this gas is passed into the washing and cooling tower, where we spray the water from the top and wash away the dissolved impurities in the sulfur dioxide. Now this sulfur dioxide along with the oxygen is passed into the another tower containing, that is called the drying tower, from the top of which we spray concentrated sulphuric acid so that the moisture which is present with the sulfur dioxide get removed. So for the drying of the sulfur dioxide, we pass it into this drying tower, from the top of which we are spraying the concentrated sulphuric acid which removes the moisture. Then this gas is passed into the arsenic purifier, where the impurities like arsenic oxide are removed, and it contains the gelatinous hydrated ferric oxide which removes the arsenic oxide from these gases, and then this gas is preheated and its temperature is raised to 720 Kelvin. Then after this, when its temperature is maintained at 720 Kelvin, it is passed into a converter, catalytic converter, which is fitted with vanadium pentoxide catalyst. This sulfur dioxide gas passes over this vanadium pentoxide, where the sulfur dioxide reacts with the oxygen, and in presence of this vanadium pentoxide, and it forms sulfur trioxide. So after this sulfur trioxide is allowed to pass into another tower, which is called the absorption tower. This absorption tower contains from the top of which this contains the cortex, and from the top of which the concentrated sulfuric acid is sprayed. This sulfur trioxide gets absorbed by the H2SO4 and it forms oleum H2S2O7. This oleum, from this oleum we collect oleum from here, and this oleum is diluted with the calculated quantity of the water so that we get sulfuric acid of desired concentration. This is how in the contact process we manufacture sulfuric acid, and this is the sketch of the plant in which we manufacture this sulfuric acid. I hope you have understood it. Thank you.